Welcome back! In this video, we will focus on the second law of motion, which is the law of acceleration. Before we start, let's have a quick review. Last time, we learned that there are three laws of motion: the law of inertia, the law of acceleration, and the law of interaction. We focus on the law of inertia, and it states that a body will remain at rest or move at constant velocity unless acted upon an external net or unbalanced force. I'll put the link of the video on the description box below for more information. Now let's have the second law of motion. During your grade 7 physics, you already learned that acceleration is the change in speed or velocity for a time interval. And you use acceleration is equals to final velocity minus initial velocity divided by time to calculate the acceleration of an object. You also use the units meter per second squared, kilometer per hour squared, meter per minute squared, and so on as the units of acceleration. But this time, we will only use meter per second squared as the unit for acceleration. Before we proceed with the law of acceleration, let's have a simple experiment. Because of our situation right now, we are encouraged to stay at home. So, our experiment for today is only an alternative to demonstrate and observe the concept of the law of acceleration. Let's start! What we need are 3 matchboxes. You can also use alternative materials like coins. For the first part, get 2 matchboxes. Question: do they have the same mass? Since they are the same, we can assume that they have the same mass. Now, flick the first box using 1 finger. Then the second box using 2 fingers. In which box will you exert a greater amount of force? Yes, that is correct. You will exert a greater amount of force in the box that you will flick using 2 fingers, and lesser force in the box that you will flick using only 1 finger. Now let's observe their acceleration. Which of the boxes have a greater acceleration? Since we did not measure the time and the distance it traveled, we will just base it on our observation and logical thinking. Again, which of the boxes have a greater acceleration? Correct! It's the box that you flick using 2 fingers, because from rest, it covers a greater distance in a short period of time, compared to the box that was flicked using 1 finger. For the first part of our experiment, we can conclude that if the mass is constant means they have the same mass, the greater the force exerted on an object, the more it will accelerate. For the second part, take the 2 matchboxes together, so they will become 1. Then, get a single matchbox. Which of the 2 have a greater mass? You're right! Obviously, the 2 boxes taped together have a greater mass. Now, flick the boxes using only 1 finger. This time, make sure that you will exert the same amount of force in each setup. Now let's observe their acceleration. Again, since we did not measure the time and the distance it traveled, we will just base it on our observation and logical thinking. Applying the same amount of force, which of the setup will have a greater acceleration? Very good! It's a single box that have a lesser mass. Because from rest, it covers a greater distance in a short period of time, compared to the 2 boxes that was taped together. For the second part of our experiment, we can conclude that if the force is constant, the greater the mass of an object, the lesser it will accelerate. And the lesser the mass of an object, the more it will accelerate. During the experiment, we had 2 conclusions. The first conclusion is, if the mass is constant, the greater the force exerted on an object, the more it will accelerate. With this conclusion, we can say that force and acceleration are directly proportional to each other. The second conclusion is if the force is constant, the greater the mass of an object, the lesser it will accelerate. And the lesser the mass of an object, the more it will accelerate. With this conclusion, we can say that acceleration and mass are inversely proportional to each other. Combining these two conclusions, we will have the law of acceleration. And the law of acceleration states that the acceleration of an object is directly proportional to the magnitude of the net force acting on it and inversely proportional to its mass. The law of acceleration can be expressed in a mathematical equation as A is equals to F over m, where A is the acceleration with the unit of meter per second squared, F is the net force with the unit of Newton or kilogram meter per second squared, and m is the mass with the unit of kilogram. Since we already have the formula for the acceleration, let's have the formula for force and the mass. We can use the magic triangle in deriving the formula of force and mass. So this is the magic triangle. To get the formula for the force, cover F. Since mass and acceleration are next to each other, we will use multiplication. So the formula for force is equals to mass times acceleration. To get the formula for the mass, cover letter M. Since force is above acceleration, we will use division. So the formula for mass is equals to force divided by acceleration. So I made this table for the summary for the formula and units. So again, the formula for acceleration is equals to force divided by the mass, and the unit is meter per second squared. The formula for force is equals to mass times acceleration, and the units are Newton or kilogram meter per second squared. The formula for mass is equals to force divided by acceleration, and its unit is kilogram. Let's apply it to a sample problem. A 58 kilogram mass huge stone is pushed with 30 Newton force. What is the acceleration of the stone? The first thing that we need to do is to identify the given. There are two ways to identify the given. First is to analyze the problem. Second is to check the unit of the given number. For example, the given is 58 kilogram. If we will analyze the problem, it says there that a 58 kilogram mass. So we already know that the 58 kilogram is the given mass. The next given is 30 Newton. Since Newton is the unit for force, we now know that 30 Newton is the given force. Since we already have the given mass and the given force, we are required to solve for the acceleration. Going back to the table, the formula for acceleration is equals to force divided by mass. So we will put the formula acceleration is equals to force over mass. Now, substitute the given to the formula. Again, the formula is acceleration is equals to force divided by mass. The given force is 30 Newton. So substitute 30 Newton to the force. Then substitute the given mass to the formula. So we will have acceleration is equals to 30 Newton divided by 58 kilogram. We need to change the unit Newton to the other unit of force, which is kilogram meter per second squared, so that we can cancel the same units. Do you see any same units? So kilogram is the same unit, so we can cancel kilogram. So what's left is meter per second squared, which is the unit for the acceleration. Now perform the equation 30 divided by 58. If you will try to compute it in a calculator, should enter first 30 then divide it by 58. What's the answer? So the answer is acceleration is equals to 0.52 meter per second squared. Let's have the next sample problem. How much force is needed to push a heavy grocery cart with a mass of 70 kg and its acceleration is 1.5 meter per second squared? Again, the first thing that we need to do is to identify the given. The first given is 70 kg. By its unit, kilogram, we can identify that it is the given mass. The next given is 1.5 meter per second squared. Since the unit is meter per second squared, we all know that it is the given acceleration. Now that we have the given mass and acceleration, we are required to calculate for the force. Going back to the table a while ago, the formula for force is equals to mass times acceleration. And the unit should be Newton or kilogram meter per second squared. Now let's substitute the given to the formula. Again, the formula is force is equals to mass times acceleration. Now substitute the given mass to the formula, which is 70 kg, and the given acceleration, which is 1.5 meter per second squared. Now, we will have force is equals to 70 kg multiplied by 1.5 meter per second squared. So multiply 70 by 1.5, the answer is 105. Then copy and combine the units kilogram and meter per second squared. We all know that we can also write kilogram meter per second squared as Newton. So the answer can also be written as force is equals to 105 Newton. If you have questions, please send it via messenger or text message. Bye!